Okay, guys, welcome back. We're going to take up a homework question. Guys, this is Unit 4, Handout 10. You'll notice that handout starts with a auto transformer, and then the rest of the questions on it are RLC parallel three-phase. The auto transformer is just for fun in there. Okay, guys, so we're going to do this one, question number 5, kind of quickly, okay, and I apologize that maybe it's a little bit difficult to see. There's a Y-connected alternator here, and then a Y-connected resistor bank, delta-connected inductors, and Y-connected capacitor bank there, and we're going to do them the same as we have been. Looks like the line voltage is 208, and so E line load 1 is 208. Okay, and then load 1 is Y-connected, so the phase, 208 divided by root 3, right guys? So it should be 120 volts. I phase load 1 looks like it's 7 ohms. It's going to be 120 divided by 7. I'll get my calculator out here, put it in the shot. 120 divided by 7. Looks like it's 17.14 volts. And then, amps, okay? And then I line load 1, because it's Y, it's going to be 17.14 amps. Okay, now we're going to do load 2. Load 2, same line voltage. All of them are going to get the same line voltage. E phase load 2, it's delta, so that's also 208 volts. I phase load 2, 208 divided by 14 looks like. Let's calculate that. 208 divided by 14. 14.86 amps. Okay. And then I line load 2. That little line right there is going to feed those two. So it's going to be 14.86 times root 3. 25.73 amps. Okay, last one. We'll switch colors again here, guys. Load 3 looks like it's Y connected. Doesn't matter. The line voltage is going to be the same, 208 volts. Phase voltage is going to be 208 divided by root 3. Comes to 120 volts. The line current, or the phase current there, guys, 120 divided by 10. Looks like it's going to be 12 amps. And then I line load 3. It's Y connected, so it's also going to be 12 amps. Okay, guys. Now, I line alternator. I line alternator is going to be the sum of the 3 currents. And I line load 1 is IR, so I can just draw that. You want to make sure you add the line values, guys. I line load 2, 25. That's lagging. It's an inductor. We'll call that IXL. Okay. And I line load 3 is 12 amps. I'm going to call that IXC. Right? And then this little bit right here is going to be IX. And it's going to be 25.73 minus 12. So minus 12. Whoops. Try that again. 25.73 minus 12. 13.73. And I total for the 3 guys. Going to be that line right there. And it looks like it's going to be 13.73 squared plus 17.14 squared. So I'll just do that. Squared plus 17.14 0.14 squared equals root equals 21 amps, 21.96 amps, and that'll be right here. And the good news is that if you do that one correctly, you'll get this one correctly as well, because it is connected Y. Okay, now all we have to do is calculate this stuff down here. We're going to calculate P. It is going to be, the line voltage of the resistor bank times the line current of the resistor bank times root 3. So it should be 208 times 17.14 times root 3, because it's three-phase. Let's calculate that. 208 times 17.14 times root 3 equals. Looks like it's 6,175 watts. Okay, guys? And we'll do load 2 here, because this is the inductor load. It's also going to be the line voltage times the line current times root 3 for that load. So it's going to be 208 times 25.73 times root 3, because it's three-phase. 208 times 25.73 times root 3 equals, okay, and it's 9270 vars. Okay, guys, and then the last one, vars XC, it's going to be the voltage for the capacitors times the current of the capacitors times root 3. So this is going to be 208 times 12, okay, times root 3. Is this easy, guys? I don't know. There's it's easy to make a mistake. Okay, so you got to go carefully. Okay, guys? And if you go carefully, it's, I don't know, hopefully easy. And just as a little reminder, guys, this here was the power, right? This here was vars XL, those two right there. And as you are fully aware, guys, these two are vars XC. Right, guys? And we're going to calculate the VA next, and that is going to be E-line total, I-line total times root 3. And I've kind of running out of room here, but let's see if we can fit it in here. It's 208 times 21.96 times root 3. Okay, guys? And so let's try that. 208 times 21.96 times root 3. Looks like the total VA for the circuit is 7911. Okay, 7911 VA for the whole circuit. Now, I'm going to do it at the end. I'm going to draw these phasors, power phasors, and see if we come up with the right answer here. But for the power factor, guys, I'm just going to go P over VA, okay? P over VA, and my power 6175, VA 7911. So let's calculate that real quick here. 6175 divided by 7911 equals. Looks like our power factor is 0.78. And I know this is all, getting crowded in here now. Okay, sorry about that. And then to calculate the phase angle, well, the power factor is the cosine of the angle, and so the angle is the inverse cos of the power factor. So I'm going to hit shift cos here, and I get 38 degrees. 0.7 degrees. And yes, I could have gone opposite over adjacent inverse tan, or figured it out any which way I wanted to. Okay? And lead or lag, guys, there's the current phasor. It is clockwise. So this guy's lagging. Now, before you go, guys, just so that I'm not, you know that I'm not lying to you, I'm going to draw these power phasors and see if they add up to 7911. All right, guys, so I'm going to draw it right up here. The true power is 6175, so I'm going to draw that guy right here. Okay, P is equal to 6175 watts. Okay, and then I'm going to draw my vars XL just for fun here. 9270, so that's going to be this long line right here, right? Vars XL equals 9270. Okay, and then I'm going to draw my vars XC. Going to come up from there, right, guys? Vars XC equals, what is it equal? 4323. Okay, and this here, vars X, right? And I can calculate it. It should be 9270 minus 4323. So let's try that. 9270 minus 4323 equals 4947. Okay, so it's 4947. Okay, and as you are fully aware, the VA is this line right here, right? There it is, the VA right there. And I should be able to calculate it. It should be 6175 squared plus 4947 squared equals root equals 7912 VA. Okay, and so here 7911 7912. Okay, so you can see that it's going to work either way, guys. And can you do it this way every time? For sure you can. Should I do it that way every time? If you want to. I mean, you can do it both ways. I mean, I do it this way. It's easier, right? But if you make a mistake, you know, you're not going to know it, right? So if you do it both ways, you're kind of double checking all your VAs and powers and all that kind of stuff. So it might not be a bad idea to draw this phasor diagram, you know, especially on the test. Make sure your answers are correct. Okay, guys? And that's all for this one. Come back and we'll start doing some power factor correction. Okay, guys?